All right, I am back today with the gift that I promised when I asked you all a couple days ago to share your gifts with me. So we had a conversation about how you feel about the long division algorithm, and I loved hearing your responses and seeing what you came up with. The long division algorithm is potentially one of the most painful processes that we subject our kids to and that we had to endure when we were learning math in elementary school. So I wanted to get in and just wrap my own head around how does this work and what exactly is happening when we take a 3 or 4 digit number, divide it by a 1 or 2 digit number, and you have to just think through so many different things. There's so many moving parts in this algorithm that you go through. And then if you step away from it for a couple weeks or months or years, it's so hard to go back and remember all the steps in what order. So I wanted to get in, break it down, see what exactly is happening with this. And I was really surprised to find out that you can put this beautiful visual on it that really makes it make sense, and gives you a handle on it so that you can see how it works and you can recreate it anytime you need to, if you ever need to do long division by hand again, so that the whole process works and it makes sense. So I was excited going through this, figuring it out for myself, creating these visuals for how it works. So I wanted to drop in and share this with you guys. And I would love to hear your feedback if this makes things click for you or for your kid. And at the end of this, I'll have some really big news to share with you, so stick around. Okay, we're going to jump straight in. There's an entire course building up to this point, and even in the division unit, there's several videos and activities. But I'm going to jump straight to the punchline here in this short video and show you why this works and hopefully leave you with a sense that it makes sense and it's rather simple to do. Okay, so let's dive in here. And before I get too far, I am fighting off a bit of a cold here, so I apologize for my stuffy sounding nose, but we will get through it. Okay, when we did multiplication, we broke down multiplication into rectangles where we had the length times the width, and then we just looked at each area separately and added them all up. So we broke 13 down into 3 and 10 more. 22 was 10, 10, and 2. And that way we could just look at the length times the width of every single one of those rectangles and add them up together. So that's the big idea at a glance of the entire multiplication unit. Okay? There's a lot of steps that go into that, but that's the big idea. So I was thinking there must be a way to break down division, because it's just backwards multiplication, into these rectangles as well. But I knew you couldn't just break it at the hundreds, tens, and ones marks, because it just wasn't working out. So I went through and figured out, what do we do if we have a problem like 682 divided by 5? Can we break it into 680 and 2 and divide each of those separately by 5? So you can pause the video if you want and experiment with that. But it doesn't work to do it that way. So what I ended up figuring out, I'm going to jump straight to the big idea here, is that what we want to do is break up our big number into groups of 500, 50, and 5. So if we're dividing by 5, we want to know how many 5s fit into this number. Now, if you can break this number down into groups of 500, then you'll know that there's 100 5s in there. If you can break it into 50, you'll know that there's 10 5s. And if you break it in the remainder into 5s, you'll know there's that many 5s in it. So we're going to take a look at this. I'm going to go through the process, show you a picture of what it looks like, and then go to the algorithm and show you how it actually makes a lot more sense than I ever thought. And hopefully this will be fun for you to see how it makes sense. And it's a pretty easy process once you get the hang of it. Okay, so 682. How many groups of 500 can we fit into there? So you can fit one 500 into 682. You can't do two 500s because that would make 1,000 and it would go over the limit. So we have one group of 500 here. Okay, now that leaves us with 182 leftovers, and that's too small. We cannot fit another 500 into it. So now we need to go to our 50s. How many 50s can we fit into 182? Excuse me. So you can do a little bit of experimenting and find out you can fit 3 groups of 50. That gives you 150. And then you're left with 32. So you can't fit another 50 in, so now we break it down and go to the next step. So 32, you can play around a little bit and see 6 groups of 5 fit into there. That gives you 30, and then there are 2 leftovers. So this is, in one screen here, at a glance what exactly we're doing when we break 682 down into groups that are divisible by 5. But let me show you with a picture exactly what's going on here. So we have our whole entire number 682 broken into rectangles, and each one of these is several groups of 5. So you break off the biggest possible chunks that you can do at a time. So we broke off one chunk of 500, and then we can't take any more 500s out, so we had 182 left over. Let's break off chunks of 50. So you can break off a chunk of 50 3 times. That's at 150. Then that leaves you with 32 left over. So let's chunk 32 into groups of 5. So you have 6 groups of 5 that can fit into 32, and then there's 2 left over. So here's our process. I know this is really fast, but I just wanted to do a short video today, not an entire class. And then here's our visual of breaking it into the biggest possible chunks, and then take your chunk and go down a notch and break it into the next level down. So let's take a look at how we read our answer from this picture. In 500, how many groups of 5 do we have? We have 100 groups of 5, so that's where our 100 comes from. Here we have, in every 50, we have 10 groups of 5. So we have 10 groups of 5, 10 more, and 10 more. So we have 30 groups of 5 there. And then in every one of these 5s, we just have 1 group of 5. So there's 6 groups of 5 there. So our answer, how many groups of 5 do we have? We have 136 groups of 5, and then there are 2 left over. Okay, so I know this is at a glance, but I hope this helps kind of make sense of what exactly is going on. And I'm going to move over now into the algorithm and just show you how this entire process gets condensed into one column of numbers. And then I've attached a workbook where, if you would like, you can practice this skill either with this whole diagram of breaking it down into hundreds, tens, and ones, or you can take this skill set and overlay it on top of the traditional algorithm. So let's take a look at what that is here. So same exact problem as before, 682 divided by 5. So our big question is, how many groups of 5 fit into 682? So start with the biggest possible chunk you can break off. How many 500s are in this number? We have 1 500 that can fit in there. So break off that chunk and see what's left. At that point, we have 182 pieces left over. We are done with our 500s. You can't fit another 500 in there. So we want to say how many 50s are in 182. So you can try 50, 100, 150 is the closest you can get without going over. So we can fit 3 50s in there. That gives us 150, and there are 32 left over. So we're done with our 50s. Let's move down to 5s. So we can fit 6 5s into 32. That gives us 30, and then we'll subtract, and there are 2 leftovers. Okay, so whether you do the process that we did on the screen before this, or draw out the rectangle and think of chunking off the biggest possible chunks you can take at a time, or whether this makes sense to you to stack it all up and do a really concise, organized list of all the steps in one. Whatever works best for you and makes sense, I just want to leave that in your hands. Hopefully this will make math that much easier and more logical. And then I wanted to transition here. This is kind of the final punchline of the end of the entire course with the long division algorithm. But prior to this, we have some activities that lead up to it and give kids a sense of what division is. So this whole course is great for all the way from beginning learners up through 3rd or 4th grade, perhaps later if you need a review of what exactly is going on with all of this math and big numbers. So we start off with some hands-on activities about dividing things into equal groups. So you see division as equal groups of things. And then we move on to the abacus just to keep it consistent, dividing a number like 16 into 4 equal groups. We'll go through and show what that means, putting one bead at a time until you have equal groups, and then there would be 4 in each group of 4. So we look at division that way. And then we talk about division as backwards multiplication. So the main part of this whole course here, for the second part of it, focuses really strongly on multiplication. And we've talked about that. We've talked about how in order to know all of your multiplication facts, you really only need to know 1s, 2s, and 10s. And even 1s are not a multiplication thing, it's just itself. So 2s and 10s are the only things you really need to know, and you can build a really strong conceptual understanding of the entire set of multiplication facts. And then once you get those down really solid, division is just backwards multiplication. And then you can move up from there into what we just talked about with long division. Okay, so that's at a glance everything that you need to know about division in a less than 15-minute mini class here. I have included a few samples from the workbook that you can go over to practice these skills some more. There's a different level, so you have these for younger kids, the long division for older kids. And I want to just end with my big celebration here that this course is finished. Okay, I've put the final touches on the final unit of the final course. So I'm done and I'm ready to start celebrating that this masterpiece of a course here, I've been working on it for almost a year, is finished and ready to launch. So I still have it for another day or two set at the pre-launch prices, and I still have that coupon code for you, BTS30. You can save 30% off the pre-launch price if you want to snag that. I'm going to be moving full steam ahead into launching this course and getting it out, sharing it. So you'll see more about that. And for those of you who have younger kids, I have part 1 of this course. I'll have an opportunity for you to snag that for free coming up in a couple weeks here. So just keep an eye out, turn notifications on in this group if you want to make sure to hear when that comes up. The division part is from part 2. So I won't be offering that part for free, but this is the best chance to get it if you're interested for the pre-launch pricing with the 30% off code. And I will be moving on once this is launched and flying gracefully through the internet. We will be moving on to a whole new theme in the Math for Fun Club, where we get to design our own carnival games. So I have a whole plan made up for that. I've been forcing myself to focus on finishing this course first, but I'm really excited to share that with you. So a lot of good stuff coming up here. So like this video or leave a comment if anything here helped make long division a little bit easier. And I will see you soon with more announcements about upcoming projects and more deals for you. Thanks for being here.